Hey everyone, today I'm going to be covering the May 4th assignment. This is the Trigonometry Quiz 3 that I assigned to my Algebra 2 classes. This stuff covers what's called sinusoidal graphs, just like we know what the graphs of sine and cosine are, and now kind of transforming them into, to look in different shapes. So, I think maybe we have the same questions, maybe we don't, but here's how you can kind of do this. Um, so they give us this equation and they want us to graph it. Now, they make it pretty easy for us to graph it. We just control these two green dots and we can move them around and we can check it if we got it right or not. Okay, but obviously there's a math way to do this. So we need to pick out of this, kind of draw out of this equation what do we know about this? So you know there's some basic facts about sine, cosine, those graphs. We have the amplitude. We know what the amplitude is. We need, or every graph has a period, and every graph has a midline. Okay, um, so if we know what these are, we should be able to graph the function if we can kind of take out what these three values are from this equation, to extract those values from this equation and find out what the characteristics of this graph is. Okay, amplitude is honestly kind of the easiest. It's just a number right here, right? So this would be blue, and this would be orange, and this would be green. Um, so amplitude is just this number right here, because this number right here, after everything is done in this little box, I multiply all this stuff by 4. So all the stuff that happens in this little box right here, I multiply all that stuff by 4. Okay, and that caused every value that I plug into my graph, I multiply it by 4. So that causes the graph to be 4 times larger. Okay, so the amplitude is 4. Now, can I graph it yet? Well, no, I don't really know. Like, the amplitude is 4, but I don't really know where it starts. Like, where it is. Is it over here, over here? Where is it? Um, this just tells me kind of how large the graph should look. Okay, period. Period is actually, well, it is kind of the most difficult to find. Um, so what I'm looking for in the period is, well, if I just graph sine of x, it looks something like this, right? It starts at 0, goes up to 1, down to -1, up to 1, down to -1. It keeps going like that, forever. So the period controls kind of how wide the graph is. Like, how spread out is it? Okay, so I really like this Khan Academy video right here that tells us like how to find the period given this graph. So we could use this method in the opposite way to find out. Let me make this. Oh, we could use this in the opposite way to take out this. So this is given the graph, find the period. We want, given the equation, find the period. Okay, and what Mr. Khan is writing here is that for period, the normal graph of sine of x, it's 2 pi, right? The period is 2 pi for this graph. I think so. So, so kind of spread out like that, I think. Well, it's not exact, but we know for a normal graph, the period is 2 pi, right? That's how long it takes to do one full cycle. One half is just pi, the other half is 2 pi, right? One whole period normally is always 2 pi. That's how long it takes to complete one cycle of the graph. That's about right here. Now, if I'm multiplying this value, if I multiply x by this value k right here, the period actually shortens. Because every value I plug in for x, I multiply that by k. So it gets kind of k times narrower, or k times shorter. Because every value of x I plug in here, this is just 1 right here, right? Every value of x that I plug in here, I multiply that by k, and so, it kind of makes, it speeds up how fast x is. So x is now growing faster because I multiply everything by k. So x now goes faster, so therefore the graph goes fast as well, and the period shortens, right? It now takes less time to do one full cycle. So how we know that in math is if a normal period is 2 pi, then if I shorten the period by k, it's 2 pi divided by k. Okay, and then he did kind of the rest of this here. But given this, I need to know what k is. Do you know what k is? I do. So the period is 2 pi over my k. What's my k? It's this value in front of x. So whatever I plug in here, whatever number I plug in for x, I multiply that by pi over 4, and so the period alters. It changes by pi over 4, whether it makes it shorter or longer. Okay, now I'm writing pi over 4 down here. Okay, now you might ask, well, Mr. Ryan, this is kind of confusing because there's a fraction inside another fraction, right? This is 2 pi over pi over 4, right? Because this is just 2 pi over k, but k here is pi over 4. That's another fraction. So I have a fraction under another fraction. How do I work with this? Okay. So I think I've discussed this in class before, but let's do an easy example. Let's say I have like 1 divided by 1/2. Okay, let's say I'm dividing 1 by 1/2. So this is still a fraction under a fraction. Okay, well, what it's asking is it's 1 divided by 1/2. So this is 1 divided by 1/2. How do I make this look? How do I simplify this? How do I solve for this, right? So just think about this. I'm dividing 1 by 1/2. Division means how many times does 1/2 go into 1? How many times does 1/2 go into 1? Well, 1/2 plus another half is 1, right? 1/2 plus 1/2, that's just 1, right? What a half plus a half is a whole. 1/2 plus 1/2 is 1. So how many times does 1/2 go into 1? 2 times. My answer is 2. Okay, so what you should see here is actually, instead of dividing 1 by 1/2, I'm actually multiplying 1 by 2. Okay, this might be a little bit hard to understand if you haven't seen this before, but hear me out. If I divide a number by a fraction, that actually is the same thing as multiplying it by the reciprocal. So I flip 1/2 over, and now it's 1 times 2. So it changes from division to multiplication, and the fraction over here flips over. So now it's 1 times 2, that's 2. That's what we had before, okay? So my point here is dividing a number by a fraction is the same as multiplying it by the reciprocal of that fraction. So what I have now over here is, instead of dividing pi over 4 into 2 pi, what I have here is 2 pi, change that to multiplication, and flip the fraction over. So how do I flip over pi over 4? The reciprocal of pi over 4, just flip it over. 4, bottom to the top, over pi. Just flip it over, that's it. So now I have 2 pi times 4 over pi. Okay, now this is something we can actually solve, right? I have a pi, so this is, 2 pi over 1, so just multiply the two fractions together. I have a pi on the top, pi on the bottom, I'm canceling them, okay? 2 times 4, 8. 8 over 1, 8 over 1, that's just 8. My period is 8. Okay, so it will take 8 units for my graph to complete one cycle. It'll take 8 units for one whole graph, for one whole cycle to complete. Okay, midline. The midline is just kind of like the amplitude, like it's this number right here. So whatever I do in this box, I add 2 to it. So every single value I have here, I add 2 to it. What do you think happens? Everything moves up by 2 because I add 2 to everything that happens over here. So my midline is going to be y equals 2. Normally, for sine and cosine, if you look at a graph, it's 0, right? It just looks like this or something. Right? The midline's 0. But because I add everything by 2, everything moves up by 2. Okay? So that's amplitude, period, midline. What else am I missing? Well, what's this number? What is this mysterious number right here? This is the horizontal shift. Okay? If you're unfamiliar with horizontal shift, you can look it up in the videos. But here's how I can think about this. Okay? So the last part of this puzzle is finding out what this part does right here. Now let's write this out. Or actually, let me ask you this first. What is sine of 0? This will help us in a second. What is sine of 0? Sine of 0, when it starts, sine of 0 is just 0. We know that. It starts here, goes up, down, so it starts at 0. Okay? Well, if I have pi over 4 times some x plus this 3 pi over 4, that's a horizontal shift, so left and right, equals 0. Okay, so I know that sine of 0 is equal to 0. So what I'm looking for is this shift changes where I start my graph. I will shift the whole graph to the left or to the right. That's what this number does. The question is, how much? Okay, now I start my graph at 0. I always start my graph at 0 for sine, right? So I want to know where I start my graph. This would be the start of the graph right here. This would be the start of the graph right here. So I always start at 0. So I want to find out what value will make this 0. Well, if sine of 0 is equal to 0, then this part right here must be equal to 0. So I could write pi over 4 x plus 3 pi over 4 is equal to 0. Okay? So some of you may be able to solve this on your own, but let's talk through this. Okay? I have pi over 4 times some number. I could choose what this number is. Plus 3 pi over 4 is equal to 0. What's different here? What's different about these two numbers? Well, the first one... my bad. The first one is pi over 4. The second one is 3 pi over 4. What's different about these two numbers? Well, there's a 3 here, right? There's a 3 here. There's no 3 here. So... for these to cancel out each other, right, these need to be the opposite number for them to be 0. Because, negative 1 plus 1 is 0, right? These must be opposite numbers. So when I add them up, I get 0. Right, so these must be opposite numbers. I have 3 pi over 4 here. What's missing here is a 3, but what's the opposite of 3? Negative 3, right? So I want negative 3 here, because negative 3 pi over 4 plus positive 3 pi over 4 equals 0. They're the same number, just opposites. And opposites cancel each other out. Okay? So I want this number here. Well, what should x be? X should be negative 3, because pi over 4 times negative 3 plus positive 3 pi over 4, they will cancel each other out, right? So I'm choosing this number right here. I'm choosing this number so that these two cancel out. I have 0. So now I know that when x is equal to negative 3, that's when I start my graph. That's when everything is 0. So I start my graph at x equals negative 3. We could actually do this now. Oops. So I start my graph at negative 3. That's where I start my graph. That's where all this stuff is 0. My midline is 2. I add everything by 2. Everything that's added by 2. My period is 8. So it would take 8 units for this cycle to complete. So 0 units. 1, 2, 3, 4, 5, 6, 7, 8. It should end at 5. Right, you see here? Oh, sorry. It should end at 5. So one whole cycle. So up, down. It should end back where it started at 5. Amplitude is 4. So 1, 2, 3, 4 at 6. Okay? Now, a couple of things you might, this is the graph, this is the answer, right? A couple of things you might notice. Amplitude is easy, midline is easy, period and the shift is hard, okay? So now pick out what you know about this graph. All I needed to find here was where does it start? If this is negative 3, then this would be 0, it would start at, so to find this number right here, I saw what made the 0. To find the period, I just did this little equation right here. Okay, let's try another one. How long does this take to orbit the Earth? Give the exact answer. Okay. Blah blah blah. T minutes after closest point zoom by. Okay, this is like a lot of information. All I need to know is how long does it take to orbit? What's an orbit? You know, it's an orbit. It's one whole cycle, right? It's all a cycle. So when I say orbit, what they're really asking for is the period. They're asking for the period here. Let me just double check this. T minutes after surgery. All right, yeah. So it's asking, what is the period of this graph? Okay. Now it's just the same thing as last time. I need to pick out what's in front of the x, right? I need to pick out what's in front of the x and use that to find the period. Okay, so what is in front of the x? So the x here is actually t, right? My t is right here. Okay, and look, it's kind of in this confusing format. So what I actually need to do here is distribute. Okay, so what I'm going to do is distribute this 2 pi over here, because then this would look familiar to us. It'll look like the equation from the last problem, right? So I need to distribute this. Yeah, so then I distribute this. So I'm only going to use this stuff because I only care about this stuff right here. I'm only looking at this. I don't even care about this stuff right here. So I will, if I distribute that, I have 2 pi t, that's this, plus 2 times 23.2 is 46.4. You can also plug in your calculator. So 2 times 23.2 is 46.4 pi over 92.8. Okay, now I have what's in front of t, but that's not it, because look at this stuff. I'm dividing everything by 92.8. Okay, I also need to distribute this. So I need to distribute this so that it looks just like last time. So that this just looks like last time, a last problem. So when I divide 92.8 into 2 pi t, I'm just going to write this out. 2 pi t divided by 92.8, okay, plus 46.4 pi divided by 92.8. I'm sorry for my bad handwriting, but what you just see here is that all I did was I took this and divided it into each of these. So I'm dividing this whole thing by this. So dividing 92.8 into both of these numbers. I'm just kind of splitting this in half. Does this look like what we had before? Yes. Okay, what's this part in front of the t? That's my k right here, right? So what's this part? It is 2 pi over 92.8. So this is what I'm looking at right here. Okay? How to find period? That's my k. Right? That's a number in front of the x. That's my k. So the number from the variable here is this number right here. Okay? So now I do, what's 2 pi divided by this? Okay? Same thing as last time. I'm actually going to use some space here. Okay, so I have 2 pi divided by 2 pi over 92.8. Okay, so you remember to turn this into something we know. I simply take the fraction. Okay, so I change division to multiplication, take this fraction and flip it over. 92.8 divided by 2 pi. 2 pi over 1. So multiply the two fractions together. 2 pi on the top, 2 pi on the bottom, they cancel. 92.8 divided by 1. 92.8 divided by 1. That's 92.8. That is my answer. Okay, now look, the answer is right here. Okay, we didn't need to do a lot of this math, but you know, if you're kind of catching on, you kind of can see this number, they affect, right? Because I'm 2 pi, it's times 2 pi times this 92.8 divided by this. These numbers right here, these constants, these numbers are affecting the period. So I hope you recognize this. Okay, it intersects the midline at 0, -6 and has a minimum point at 2.5, -9. Okay, so it actually just is like what, they're doing here. So you could always watch these videos if you need help. So let's kind of graph what this looks like. Well, actually, let's first take out the numbers. So the midline. Okay, let's graph this. Sorry. So so the midline is actually this part right here. Right, so it intersects the midline at 0, -6. That's this point right here. Okay. So it intersects the midline at 0, -6. That means the midline is down here. That's the midline. Has a minimum point at 2.5, -9. So over here, that's the minimum point. That's 2.5, -9. And then I just graph it like this. Okay. So first of all, to write, or let me take out the values here. The midline, what's this? What's this line right here? It's at 0, comma, -6. So the midline is y equals -6. Amplitude. Amplitude. How tall is the graph? Well, to go from the middle down, this is the amplitude right here. So just kind of how large the graph is. So what's this point? This is -6. What's this point down here? It's -9. So go from here to here, I go down 3 units. So it's down 3 units. The amplitude is 3. I head down 3 units, so the amplitude is 3 right here. Okay, so period. What is the period? Okay, well, the period is kind of this length right, or it helps us think about this length right here. What's this length from 0 to 2.5? So it's distance of 2.5. So that's all the way down is 2.5. Okay, now going back up to 0, what do you think it is? What do you think this distance is? It's also 2.5, right? It's all symmetrical. So if I head down in 2.5 units, I head back up in 2.5 units. If I start here in 2.5, if I start here, head back up, what do you think this is? 2.5. So head down 2.5, head to middle 2.5, head up 2.5, head back down to middle 2.5. Okay, so what's 2.5? Plus 2.5 plus 2.5 is 2.5. That's 4 of these. So 4 times 2.5 is 10. Okay, so my period, so this is actually, that's actually my number k, right? One whole cycle takes 8 units. So my k is, or my period will be equal to 8 units. So we need to figure out what k is, sorry. So my period will be 8 units. I need to figure out what my k will be here. Okay, so 2 pi over k is equal to 10. The period is 10 units. Now I need to figure out what k is based on how many times, like, what does k need to be for this to be 10? Okay, so you actually can take the reciprocal of both sides. That helps a lot. So take the reciprocal of both sides. K over 2 pi is equal to, this is 10 over 1 over 10. Now we can multiply both sides by 2 pi. Multiply this by 2 pi. 2 pi by 1. So 2 pi on the top, 2 pi on the bottom, they cancel. Okay, now what cancels here? So the 1's cancel, but I don't really care about that. The 2 here, I cancel the 2 here because 10 has a 2 in it. If I take out a 2 from 10, I have 5. So 1 times pi is pi. 5 times 1 is 5. My k here is pi over 5. Cool. K is pi over 5. I think I have everything. Is there any vertical horizontal shift? Doesn't look like it. Right? I started, if there were, it would start like over here or over here, whatever, but it starts, the middle is right here, so it looks like I'm fine. Okay? Now, the amplitude is the first thing that's 3. Is it sine or cosine? Okay? You remember, sine looks like this, cosine looks like this for one cycle. Right? Sine starts at 0, cosine starts at this. Okay? Now, it doesn't make sense for it to be cosine. See, okay, so you see how this graph looks like sine? So it is actually sine. And this is kind of just based on my thinking. Whereas if it was cosine, this it makes more sense for it to be sine, because from the middle down, middle up, so it looks like it's easy for me to do this is one cycle right here. So if you look at one cycle, it looks like the graph of sine, but it's actually flipped over, right? The normal graph of sine would look like this, but this is flipped over. So how do I fix this? I change the 3 to be negative. Okay, and that will flip the graph over. So 3 sine, what's this number? What's my k? It's pi over 5. Pi over 5 times my x. Okay, there's no horizontal shift, so I'm done here. And then what's left over? The midline is -6, so minus 6. Okay, we're almost done. We have 2 more to do. Okay, now that I've explained this, I'm just going to be following the steps here. Amplitude, what's this number? 5. Midline, take out the -4. Midline is y equals -4. Period. K is pi over 2. So from the period, I do 2 pi over k. Okay. So that's 2 pi divided by pi over 2. Okay. Change this from division to multiplication. Flip over the fraction. 2 over pi. Okay. So just like we did before. Pi on the top, pi on the bottom, they cancel. 2's on the top. 2 times 2 is 4. 1 left over, that's just 1. My period is 4. Cool. Is there a thing right here? No, there's nothing here, right? There's no plus or minus whatever in here, so there's no horizontal shift, and we're actually done. Okay, now we can graph it. It will say like this, but the midline is -4, so the middle will be down here. Amplitude is 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep. Period is 4. So one cycle will be 4 units. Oh, I think that's it. So amplitude is 5. Up, down, back. That's 4. That's 4 units, and I think we're done. Perfect. Okay, this one. So if you're stuck on how to do this, look back earlier in the video. Okay. So now to graph cosine. Let's pick out what we have. Amplitude 3. Mid. Oops. Y equals 4. Because that's this number right here. That's the amplitude. That's the midline. Y equals 4. K. My K is 2. That's the number in front of the variable. So it's 2 pi divided by K. That means it's 2 pi divided by 2. 2 on the top, 2 on the bottom, they cancel. Just all that's left over is pi. Cool. Period is pi. Okay. Lastly is this number right here. That's my horizontal shift. Okay. So what I'm asking is, I want to know where I start cosine. Okay. So you know that cosine of 0 is 1, right? Oops. Cosine of 0 is 1 because it starts up and then heads back down and up, right? So cosine is different. It's such a 1. But I still want to know where my 0 is. So 0 is equal to 2x plus 6 pi. Okay. So all I'm asking is what number x should this be for this to be 0? Because I know that's when cosine starts. Okay. Now I'm just going to do this algebraically. Move this over. Okay. So I have negative 6 pi. I move this over to the other side. Make it opposite. 2x. Okay, now, so I undid this. I'm going to undo the multiplication. So divide by 2. Okay, negative 6 divided by 2 is negative 3. I have a pi over here. That's my x. Oops. That's my x right here. Nice. Okay, so negative 3 pi is equal to x. Cool. That's where I start my graph at 1. So let's finish this off. Alright, so at negative 3 pi, that's where I start my graph. I started at 1. Cool, I start my graph at 1. So it looks like being, okay. This may be, alright. So, okay, sorry. I start my graph at, so it looks like being like this. Alright, it looks like cosine, it looked like, it'll look, can't draw on this. Oh, well, period is 2. Oh, sorry, period is pi. Period is pi right here. Period is pi, so it should take pi units to complete one full cycle. Oh, wow. I think that's, yeah. So, start up. Oh, sorry. Yeah, so this will take pi units to complete one full cycle. Start at the top, down, up, one full cycle, down, up. That's negative 2 pi, so that's the period. Midline is y equals 4. So the middle will actually be at y equals 4. And, so this one's a little bit harder since it's cosine. Let me see what I could do. And the amplitude is 3. So 1, 2, 3. That's good. I think this is it. Right, amplitude's 3, so it takes 3 units. 7, 1, 2, 3. Yep, midline is 4. Period is pi. Down, up is pi. That takes pi units. And starts at negative 3. Cosine starts at 1. So it'll start at 7. I think. Alright, perfect. Hey, so a bit hard, right? This is probably, this is like, I wish, this kind of thing I wish we could have done in class. But, the reason I'm doing this is to, hopefully you can kind of catch on to what I'm doing here. And if you have the same questions, you could probably just put in the answers. But what I'm really looking for here is that you kind of are catching on to my thinking about this. And look, I'm referencing the videos as well. I don't know this stuff on the top of my head. Right, I need to look at this too to remind myself, oh, that's how I do this, okay? So you need to look at, or you should look at the resources they provide for you. Like watch the videos, use hints, whatever, okay? So hope this was helpful, and I will see you later.